So if there's one reason why I'm doing this, my goal is to create an algorithm of video content that would be suitable for anyone to prepare for their exams, regardless of what grade you are, as long as you are in high school. So with that being said, some of the questions that I do may seem easier for students who are already at a higher level, but then whatever we are doing is useful to someone out there, believable that it is a past question paper question, or rather the information that we do or the questions that we do are selected from the previous question paper of whatever grade it may be. So now I want us to step up a bit from the stuff that we did previously. The question that we did last time, it would accommodate for grade 10 students, right? So now, if you are in grade 11 or metric, the question of the very same type of information, whereby we are still using a diagram to determine the trigonometric identities, but not just a diagram as such, but a Cartesian plane. Now, if we step up, the question is going to look like this. So this one also is selected from a previous question paper of grade 11, which also accommodate for grade 12 students as well. So now the question reads, in the diagram below, as we are looking at the diagram, right? In the diagram below, R is a point in the first quadrant. So remember I said the quadrant matters. First quadrant, second quadrant, third quadrant, fourth quadrant. You must look at the behavior of your identities. And this one is going to help us analyze that very well. Now, let's go. In the diagram below, R is a point in the first quadrant such that TOR, angle TOR is equals to alpha, as we can see. And then RO is extended to P. Okay, sharp. So RO is extended to P such that OP is equals to 2RO and angle TOP is beta. Furthermore, it is given that sine alpha is equals to 3 over 5. Sine alpha is equals to 3 over 5. In your head, it should ring that sine is opposite over hypotenuse, whereby sine is y over r. Hold that thought. Now, as we are analyzing the diagram, and the questions goes whereby without using a calculator, we have to determine now there we go, and we have to determine the expressions and stuff like that. But that's not the point. Now, let's analyze the diagram the way I say we should look at things. So now, before we answer any question, let's analyze our diagram just for other important stuff that we think we might have missed out. First of all, you must know that on the diagram, in terms of the angle, this is 0 degrees. This is 90 degrees. This is 180 degrees. That's when the angles are rotating now. This is 270 degrees. And then if it rotates back, it comes back to where it started, and we have 360 degrees. And we know that this is the first quadrant, right? This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. That's what we know. And again, if there's one more thing to remember is to know that in the first quadrant, we know that the first quadrant is 90 minus, in terms of beta, this is going to be 90 minus beta or minus theta or minus x, regardless of the angle. And on the second quadrant, we have 90 plus alpha or 180 minus alpha, because of that's where we are. On the third quadrant, we have 180 plus alpha or 270 minus alpha. And then on the fourth quadrant, we have 270 plus alpha or 360 minus alpha. And then if we rotate back, we know that also on the first quadrant, again, we may have 360 plus alpha, like that, if I look at it in terms of alpha. Also, if I look at it in terms of beta, it would be 90 plus 90 minus beta, like that, like that, like that. I just believe that this information may be helpful at some of the point when we are calculating the questions. But sharp, let me just put that here. But now, based on the quadrants again, for this question, the only quadrants that are involved is the first quadrant and the third quadrant. And for the points of R, I know that I expect R to be positive X and positive Y in terms of the point, because it's on the first quadrant. Both the X-axis and the Y-axis are positive there. And for P, because P is on the third quadrant, I expect X to be a negative, I expect Y to be a negative, because both X-axis and Y-axis are negative on the third quadrant. So now, for the first question, 5.3.1, I am required to determine 10 of alpha. 10 of alpha. I just need to give the value of 10 of alpha. But what information do I have? I have that sine of alpha is equals to 3 over 5 based on the information that I'm given. And I know that sine of alpha is equals to y over r, meaning from this information, r is 5. R is equals to 5, and then the value of y in this case will be 3. Now, I just need to get the value of x. And to get the value of x, what do I use? Pythagoras Theorem for this part. So to get the value of x for this part, I will say x squared plus y squared is equals to r squared. Therefore, x squared is going to be r squared minus y squared. Therefore, what do I have? R is 5 squared minus 3 squared. Therefore, I will have 25 minus 9. And 25 minus 9 is 16. But remember, this is x squared. I'm looking for x. So if I put the square root both sides, I will have that x is equals to plus or minus 4, right? Now that I have plus or minus 4 for the value of x, which is supposed to go in there. Now that I have plus or minus 4, how do I know if I choose the plus or the minus value for the value of x? Because R is on the first quadrant, and I know that x throughout there will always be positive. So I have to take x as positive 4. Otherwise, it could have been a negative if it was on another quadrant. But because x is on the first quadrant, I have to take a positive 4 for the value. And then having all the points, it would be easy now to determine 10 of alpha. Now look at this. 10 of alpha is equals to y over x, because I know that 10 is opposite over the adjacent, which means that 10 of alpha is going to be y is 3 over x, which is 4. So that's the value of 10 alpha. Okay, cool. Now, for the second question, 5.3.2, I am required to determine sine of beta, right? Sine of beta, this angle here on the third quadrant. And what do I know? I know that sine, it has to be y over r, right? And I know that y has to be a negative value because it's on the third quadrant, and then with the value of r there, r which is OP. But I already know the value of r somehow. How do I know the value of r? On the question, it was mentioned that OP is equals to 2RO. And RO is 5. That's where R was equals to 5. This part here, RO is 5. So if RO is 5, This means that OP will be 2 times 5, which means OP is 10, which means my R here is going to be 10. Therefore, in terms of beta, I now know something. Sine of beta is going to be y over 10. Now, how do I get the value of y? Because that point here is not given at all. And I can try whichever different means I would, but it would be challenging for me to get the value of x and y here with the information that I have. But here's the thing. Angles are relatable. If I know that sine of alpha is equals to 3 over 4, however, beta is on the fourth quadrant, such that I can relate that beta is the same as either 180 plus alpha or 270 minus alpha. But then I'm just going to choose this one. So let me say beta is the same as 180 plus alpha. What does this mean? It means that sine of beta is the same as sine of 180 plus alpha, meaning I can represent beta in the form of alpha if I wanted to. And in this case, what do I know about my trigonometric identities? I know that on the first quadrant, all of them are positive. I know that sine is positive on the second quadrant. So on the second quadrant, sine and its reciprocal, which is cosec, they are positive on the second quadrant. On the third quadrant, only 10 is positive. And then on the fourth quadrant, it's cos and sec that are positive. So now in this case, I know that sine of 180 plus theta is the same as minus sine of alpha, because sine is negative on the third quadrant. But I already know the value of sine of alpha, because it is given that sine of alpha is 3 over 5. So therefore, this means sine of beta is going to be just the same as minus 3 over 5 if I substitute there. So I will have minus 3 over 5, which means sine of beta is the same as minus 3 over 5. That's the best way I can express it, because using the information of beta, I don't have enough information to can use it like this. But then because angles are relatable, beta is the same as 180 plus alpha, then I can relate it like this. It's very much the very same approach, because at the end of the day, you will punch that in a calculator and get it in the form of decimals. That's how we do 5.3.2. I strongly hope everything would be way more simpler than it already is. But then guys, Einstein once said, everything should be as simple as possible, but not simple. But over that, a question may look as difficult, or it could be more simpler based on the level of the grade of the question. So at some point, we just have to scratch our heads and think deeper, because at the end of the day, the examiners, they are hiding marks in the question to make sure that you have to repeat a grade to keep on paying. But then to find your way out, just be as ready as practice further and make sure that you can see the differences or different approach of how to approach a question, just like we've done on 5.3.2, which takes us to 5.3.3. And for 5.3.3, we have to determine the coordinates of P. Now, this is where, now 5.3.3, we have to find the coordinates of P, which is this point here. Now, this is how important everything we've been doing come together. Look at this. First of all, I know that sine of beta, I can represent it as y over 10, but I just didn't have enough information to can represent it like that. Hence, I ended up settling for this. And I found that the expression for sine beta is the same as minus 5 over 3. If I know that sine of beta can be expressed as y over 10, but then I found that it is actually minus 3 over 5, it means I can take advantage of that and say y over 10 is equals to minus 3 over 5 because these are both the expression for sine beta. And if I solve for y here, if I cross multiply, I'll get that 5y is equals to minus 30. And y will be minus 6. That's the value of y. And actually, I expected my y to be negative because point P is on the third quadrant, meaning the value of y is minus 6. If I know the value of y, I have the value of r, then I can get the value of x again using Pythagoras theorem. So therefore, x squared plus y squared is equals to r squared. Therefore, x squared is going to be r squared minus y squared. Therefore, r squared is 10 squared minus r is minus 6 squared. Therefore, I will get 100 minus 36. This is going to give me 64. But hey, I'm looking for x. I still have x squared. So x squared is equals to 64. If I put the square root both sides, I will find that x is equals to plus or minus 8. Now, since x is plus or minus 8, how do I know if I choose the negative value or the positive value? With this one, I will settle for the negative value because I know that the point I'm looking for is on the third quadrant, and at that third quadrant, x has to be a negative value such that the value of x is going to be minus 8. I would settle for a positive value if it was on the first quadrant, but because it's on the third quadrant, I settle for a negative value, meaning point P is minus 8 and minus 6, which is what I expected from the third quadrant. And look at this. Now, someone may say, how does minus 3 over 5 relate to y over 10? In a perfect world, if I had to find sine beta using this, now that I know the value of y, it means that y would have been minus 6 over 10. And minus 6 over 10, trust me, you all see what is going. This can be divisible by 2 both sides. 2 goes 3 times here, 2 goes 5 times here, and would end up being the same as minus 3 over 5, which is the very same value as how it is here. So that's how the whole thing works. So that's how far we can go with questions like this. I hope everything makes sense. Otherwise, if you've watched this far, please don't forget to subscribe to our YouTube channel, follow us in all our social media platforms, and feel free to inquire about our private lessons. We do offer private lessons at a very reasonable price. You can send us a WhatsApp or an email from any of these contact numbers. I'm Mr. My Money. This is Simplified RSA. We are the guys who makes it look easy. And we are here to create that algorithm of videos that's going to assist you in preparing for your exams, just to make sure you get a very good mark. That's it for today. Until next time, join us as we do more content that is relatable to this.